this is going to be a technical talk. I would like to assume that you are familiar with what explorable explanations are. I could give a great big explanation here about what we're about, but really I feel like to develop as a medium, we want to be able to assume familiarity, we want to be able to have advanced discourse or something like that. It's not that I want to be exclusive, but yeah. So apologies to those of you who've never encountered explorable explanations before, but if you haven't encountered them, then this would be some good places to start. And to give a definition of what I'm going to be talking about today, unintuitive action at a distance is things interacting with one another or changing one another without them coming into contact, without them colliding, or without anything happening in between them. And the argument that I'm going to give today is that action at a distance, unintuitive action at a distance, is something that we should keep out of our mechanics when we are designing explorable explanations, and indeed when we are designing video games. But yeah, so the structure of this talk will be that I'm going to talk about how there is a huge amount of unintuitive action at a distance in explorable explanations. It's a big problem, or rather it's a problem at the very least that I have had. I'm going to give a bunch of examples, specifically 6 examples, but I actually had the experience of writing this talk, and there were 5 examples, and I was going to give this talk a while ago, but something delayed it, and since then I actually made exactly the same mistake again. And yeah, so I've had to constantly look out for action at a distance within my own work and get rid of it, and I would claim that there are at least a few other people who in their explorable explanations have done it. But the strange thing is that there is almost no action at a distance in video games. It is a really big discrepancy. This is my claim. I could be wrong about it, but yeah. And in part 2 I'll argue that, and in part 3 I'll just sort of ruminate on what this means for us. So yeah, part 2, part 1, unintuitive action at a distance in explorable explanations. And so first I'm gonna, this is the thing that you might have seen of mine, Virus the Beauty of the Beast, and I want to show you the interface as it used to be.
Hello YouTube, this video is part of a demonstration that's really meant to be interactive, and you can see the interaction a bit more and using this button.
You're probably familiar with this. Hopefully that's not too small to see in our 720 pixel output. Yeah. I think that's enough of that. Okay, that's what the final interface was for Virus the Beauty of the Beast, or at least that part of it. But in the first version of this project, here's what it looked like. This is exactly the same stuff as what you just saw, except represented in a different way.
And if we look down here, we also have a pattern
this was sort of a few
navy blue.
days
There's a
into
relationship
development.
between these 2 bunches of triangles, which I will just illustrate.
It has to sort of be introduced first. You have these
It's
2
just like
separate
wrapping
things,
paper
one
for a
up top
present.
and
The
one
triangles
on the
down
bottom, and now I'm
here
just
are sort of flattened out
describing what
version
you're seeing,
of
which I
the
don't want to
triangle
do.
of the shape up here. And here's what the software does. I can grab the triangles that are outlined in black down here, and I can alter them slightly, which changes the shape.
There's the
up
weird
there.
part.
And this might be a little bit confusing to look at, but again think of this as a cutout from this pattern down here. And in a very simple way using the mouse, I can make the triangles on it bigger or smaller, and I can twist them this way and that as well.
This looks weird, but this is, in a mathematical sense, showing you exactly the same thing as what I showed you over here. That was the original interface for it, and it's much worse, it seems to me. obviously. Obviously I feel that way because I had to put in the work to change it. It's worse because it's more confusing. It's really weird to look at. The interface for this thing, you're sort of changing the orientation and scale of this pattern of triangles at the bottom, and you're seeing this weird thing happen at the top. And this is the sense in which it is showing action at a distance. There is a thing up here which is being modified somehow by something that's down here without them touching. And it showed at the beginning, like there's this. It tried to sort of show in a visual way this connection between the two,
as you can
but
see,
it really,
just like
it doesn't really back it
triangles
up.
down here,
It's hard to sort of keep that in your
flattened out
head.
version
I
of the
thought it would be
shape
easy,
up here.
but it definitely isn't. But I'll say this, like, when I was starting to design this interface, I knew I had this choice. The choice, to be clear, is you have a flat pattern and you have a wrapped up version of this pattern. With the final interface, you see
pentagons in there.
You see them. It's the same thing. You actually press a button and it cuts the whole thing out. But in this, you get on the left-hand one, you get you see both at the same time, the wrapped up thing and the flattened thing. And I thought that was a really good idea. I thought that was really, really interesting because I was like, well, so it'll be like a special sort of control method. Like you're controlling these two parameters at the same time, the scale and the orientation, and you're watching something change in real time. I thought that was super cool. Like in my head it would be like looking at some like lenses or something like this, some interesting lenses. And in a mathematical sense, there's a mathematical sense in which this interface on the left is truer, because what is happening mathematically when we talk about these patterns, this kind of the model of what I'm showing you right now, we're talking about a mapping. We're talking about a mapping from the plane to the sphere, and so in some sense you should see the sphere and the plane at the same time. But that's not an intuitive way for a human being to see it. It turns out. And even if you had told me, if you had told me, oh, don't do it this way, don't have them showing at the same time, you have to do it this way, you have to alternate between the two, I would have said, no, this is going to be great, there'll be this weird, like, you watch this instantaneous mapping thing. So it's sad to me that my arrogance might have gotten in the way of me taking the advice that I'm giving right now. I would also have argued to you that with this thing, it's good to see them both at the same time because you get something instantaneous going on, and that builds up the intuition in your head. But like, I don't think that'll ever be intuitive. You can play around with it as long as you like, and it won't be. Okay, so that's example number one. Example number two is a thing which is not public yet. It will be public pretty soon. It actually is pretty crazy. It had 4 separate windows in its original version. One of them was this square, and you were sort of exploring this the space of the square. Another was this Klein bottle, and you could see as you moved this point around on the square, you'd see it instantaneously moving around on the Klein bottle. I don't want to go into detail about what this project was about, but I did have good reasons for making this thing. And that on its own is not that bad. It's still sort of a bit weird. And then at the same time, you would see these two things down here, where one of them is a mapping again from this square to a sort of parameter space, and then another one is, this is actually meant to be a bunch of neurons, and again, I thought it would be super cool to see a bunch of things changing at the same time, and affecting one another, but there's just absolutely no way to wrap your head around the mapping between all of these simultaneous things. And I've ended up I ended up redesigning it. You'll see this redesign soon, but yeah, once again, first of all, I had to collapse both of this top right thing and this top left thing into the same thing. Like I had to do that. So with the final version, you directly manipulate a point moving around on the client bottle, and that's at least simpler. And it's because I managed to keep it simple, it's not so bad to look at this mapping. Like, again, we're thinking about you move something around on the left and it does cause a change to this thing on the right. It's not that hard to wrap your head around in this case, but yeah, seeing things all happen at the same time, it's weird. Now I can demonstrate something to you again. I'm not doing this in chronological order at all, by the way. This project I worked on before Virus: The Beauty of the Beast. This is a very recent project, as in the last couple of weeks. I've been working on stellations of the icosahedron, which is this rather interesting little thing that you can read about on Wikipedia. And there was a book by some geometers about it. It's a rather nice bit of geometry. Here is where I am with the prototype for that. I'll just show it to you. So you start out with this icosahedron, and you can grab the edges and you can pull out extra new faces for this. Look, this looks pretty weird, but it is, once I've worked on this interface a bit more, it'll be pretty intuitive. It's just following my mouse. I'm creating new spikes by moving the mouse around, and I can do nice looking things like this, and there we go. We've got a nice weird looking star thing here. But my original design for this interface was completely different. It was much more based on the conventional way of representing the stellations of the icosahedron. There is actually, I found out that somebody had already implemented an interactive version of the concept of stellations of the icosahedron in this program called Stellar 4D, which is a very interesting program. However, they represent it in this way, where you have this sort of diagram, and you can like fill in faces, and it sort of adds extra spikes in that way. Yeah, again, not a whole lot of point in going into the detail, but I was going to implement my interface this way as well. You're just sort of like basically this tiny little triangle in the middle is the face of the icosahedron, and these extra things that you pull out become new faces. These extra things that you pull out become those faces. But it's not very clear why these points end in the places that they do. So I have no doubt that this redesign for the interface makes a lot more sense. Yeah, that's still got a little bit of work to be done on it. But so yeah, I was sort of being constrained in my original design by the idea that I need to have this diagram on the right here. And that diagram on the right does make sense if you've read a bunch of words, but yeah, this way feels a lot better. The idea of reaching out and grabbing something is just nice. And actually, this was the most recent one. I had 5 examples from my own work for this talk, and then I took a break from this talk started working on this project, and I was totally about to do the action at a distance thing again. I was totally about to have, like, you manipulate this thing on the right and something weird happens on the, and something, it maps to something on the left. But, yeah. And it was when I realised, oh, do you know what, I should probably try to adopt my no action at a distance principle. And then I came up with this redesign for the interface. You know, it's a pretty obvious way of doing it. So I may have had it without trying to follow my principle, but yeah. Let's show you something nice with this. Why not? Oh, come on. Yeah, there we go. Yeah, doesn't that look nice? Okay, and that'll be out soon enough. These are two different explorable explanations. Well, in this case, these are two projects of mine where I got to work on them, and I don't have any comparison to show you. But if you imagine in your... So this one on the left here is something that I made. It's a model of the spread of measles. You can see it at this link down here, hamishtodd1.github.io/sysmic. First S is capitalized. I don't know if that actually matters. But yeah, this is like action at a distance up the yin-yang. You've got a parameter space that you can control. You're watching a phase plot. These two things again represent the same information, but in a funny sort of way. I would like to work on something about dynamical systems it's about dynamical systems, and I'd like to work on something like it in the future, but the way that I'm probably going to do it is try to, like, you press a button and this representation here sort of transforms into this representation here. Yeah, that's probably the way to do it. As it is a little bit nice if you try this thing out to move this point around the parameter zone, and that causes changes to the phase portrait that we've got up here. It's kind of nice, but it certainly, I don't think it teaches you that much. It's just a weird mapping to try and have in your head. So it's like, oh, it's a cool toy and you can, like, move something around and things, like, distort in a weird way. But yeah. And then once again, there's something in here about different ways of representing information. For my PhD project, I'm working on a piece of actual software. It's not an explorable explanation, that is about manipulating protein structures, basically. And there's a certain kind of plot called a Ramachandran diagram that we have for understanding data on angles between bonds in a protein. And I was designing an explorable explanation where you move a point around a Ramachandran diagram, and it causes changes in the protein, but it feels pretty weird. And the better thing to do would be to find some way of representing that information actually on top of the bond. So it's not like, oh, I'm looking at this Ramachandran diagram, oh, I'm looking at the bond, and I have to, like, sort of alternate my view between the two. No, you should be, we need some way of, like, taking this and, like, wrapping it around like a donut here or something like that. So interatomic forces is something that has been done in Explorable Explanations, and it's worth talking about here. I want to compare something that I did. This was a sort of virtual reality lecture that I did. It's kind of like an explorable explanation, is certainly in the sense that, like, I was using interactive technology to display things, and then I would have kids come along and play around with stuff in the simulation. If I take you to 9 minutes 39. So this is a part of the lecture, this presentation, where I've got these two atoms and they're sort of attracted to each other, but they're also repelling each other, and that's how bonds work. Yeah, I sort of have them there, and doesn't that look weird? Doesn't that look so weird? Like, that's the way that atoms actually are, but, you know, it's much better to have something like what Andy Hall has in this wonderful game called Bond Breaker. For those of you who like Explorable Explanations but you're not familiar with the work of Andy Hall, I encourage you to look up Bond Breaker, it's really good. He's got interatomic forces as well, but you can see how when he moves so you can see here, you've got some green stuff going on between this atom and this proton, and even though that doesn't happen in real life, there's not, well, I mean, quantum chemistry is complicated, but like there's certainly, like when an atom approaches a proton that might be attracted to it, there's certainly not a bunch of green things that go back and forth between them. But that is something that's pretty necessary to have in the game, and so Andy Hall spent a long time working on this game that involves interatomic forces, and he worked out faster than I did that you need to have some visual representation of the attractive and repulsive forces between them. Moving on to other people's work now. This is an interesting animation by a guy called Niles Johnson. It is about a thing called the hop vibration. It's once again a quite beautiful animation, but it does not, in my opinion, give you that much of an idea of the hop vibration, because it's weird. It's too weird to look at. You can read about the hop vibration on Wikipedia, but basically there's once again a map. There's two different objects here. We've got an object down here and an object up here, and there's a mapping between these two objects that this animation is meant to display, and it's very pretty and cool distortions. But it doesn't give me an intuitive idea of how the hop vibration works. I feel it's perhaps unfair of me to say something like this. Maybe I should sit and let you watch this for a while. Yeah, isn't it gorgeous? I think basically that there might be a better way of representing the hop vibration. Like if something about like choosing a point on the sphere and then it explodes into a circle or something like this. Yeah, hop vibration fibers and bass is the name of that animation. Yeah, again, it's just slightly weird, at least for me, to look at. This is an interesting virtual reality explorable explanation called CalcFlow. It involves manipulating a point in a parameter space again, and seeing these interesting changes that it creates to three-dimensional surfaces. Beg your pardon, two-dimensional surfaces in 3 dimensions. It's quite interesting, fun to play with, but I think there might be a better way for us to do this. Gravity simulators are a thing that you see a lot. They've, you know, probably since, I mean, okay, the very first video game involved some simulation of gravity, so there you go. The very first video game was, Space War was, in a sense, an explorable explanation that told you a little bit about gravity. In general, when you depict gravity in something like this, for example, I've got Andy Hall's gravity simulator here, Universe Sandbox is another. You depict gravity in the way that it actually is, which is you have like a planet or whatever, and something like orbits that planet, and that's actually not satisfactory. That's not the best way of doing things. I think that very similar to this interatomic forces thing that Andy, the depiction of interatomic forces in Bondbreaker, which we'll come back to Bondbreaker, by the way. It might actually be good to see gravity, like when two things get close to each other, you know, a connection between them comes into existence, and that shows you which things are being attracted to which other things. Because in Andy Hall's gravity simulator, like, you have things moving around and you're not exactly sure which ones are connected to what, which ones are sort of being most influenced by what. This is a very famous video, something like 20 million views on YouTube, depicting gravity in another way. It's really wonderful. One of the reasons it's quite so wonderful is you see how a planet can be influenced by the curvature of the thing of the space that it's in. Back to Bondbreaker, though. Good as this is for depicting interatomic forces, there's this one thing in it which has a bad case of action at a distance. It's at 751 in this video. To be clear, in this game, like, I should have said this earlier, you know, you are this atom and you're moving around, you can interact with electrons, you're trying to get the star. And there are these things floating here. You just picked one up, and they're like, they are in a sense power-ups, in the sense that they cause a state change. Watch what happens when it picks up this purple one. So, I don't know if you saw it, but that purple thing caused a change to not just the avatar, but to the atom on the right. Watch this atom on the right. It had an electron bounce to a different orbital. So it's sort of that picking up one of those things powers up every atom in the level, and so it's a classic thing in video game design that something has happened and the player the player isn't aware of it, and you've got to like work hard to make sure that to draw their attention to something. But I claim that there's at least in the way that this power-up is depicted, there's something inherently unsatisfactory. So what happens is you pick up that thing and it sweeps this whole thing across the level and it causes various state changes. But even if you know that that's going to happen, it feels unpleasant to me. It seems obvious that it would have been better to have something like, you pick up that power-up and that causes... it zooms off screen and it becomes a bunch of lasers that all point at all of the atoms on the screen, and it shoots things at them, and that causes their electrons to go to a different orbital. And that would probably, hopefully you'd find a faster way of doing that. It might make people feel bad that, you know, that's a less honest way for things to happen, because this is more like how it actually happens in the real world, and because the thing that you're trying to depict here is lasers hitting a bunch of atoms. But there's a trade-off between veracity or honesty and clarity / entertainment, and that I think that would have been a better way of doing it. One last example. This isn't an explorable explanation, but you've probably all seen this talk by Brett Victor. If you haven't, you definitely should. Very good talk. He's got a nice design for a visual programming language in this. I don't know very much about visual programming languages, haven't read any literature on them, but so far as I know, this is pretty clever. And watch what he has here. He has, this. He's used this thing on the right, which he then hides, to set up a little behaviour in this pseudo-game thing that he's got. It's great. But it's... assuming that you've seen this lecture, it's plausible to me that the visual programming language would do well to have some kind of even more contrived, like Rube Goldberg thing connecting those two things. That might sound like you have more objects connecting them, and then it would be more intuitive, and this visual programming language might become something that people could learn a little bit easier, and when like looking at the scene, they would be able to instantly read off everything that's going on a little bit more easily. Some people might say, well, gosh, that would certainly, if you had more objects in this scene than you need, then that would crowd things out. Yeah, and that's a problem, and I would say that it's a problem inherent to this that might be inherent to this idea of a visual programming language. I'm optimistic about it, but yeah, it might be a problem that you have action at a distance. If you have to have that. Okay. So part 2, part 1 seems to have taken something like 25 minutes. Part 2 and 3 are much shorter. Part 2, there seems to be almost no action at a distance in video games. I'm making a bit of a claim here. To be clear, action at a distance, to say it again, you have some object and some other object, and something happening over here causes a change to something over here without any intermediate stuff, or any implication of intermediate stuff, and it's like a sophisticated change. And I'm making a big claim here. I have thought I have thought about this quite a lot. I can't think of any examples of action at a distance in video games. It's very plausible to me that one of you will be like you'll embarrass me by saying, oh, here's a really, really obvious example. But yeah, to go through the closest things to examples that I have found. So they all games seem to be based around collisions between objects to some extent. You might say a real-time strategy game interface involves action at a distance, because let's say that you click upgrade troops, and you've got a menu, and you've got some troops here, and they become upgraded. In a sense, that's action at a distance, but I'd claim it doesn't quite count, because the interface for an RTS is something that people consider to be independent of the simulation itself. Maybe that sounds like I'm cheating, but yeah, I think that there's something in this. Nano Pandas is a great game that has action at a distance in its mechanics. The whole game is about attractive particles. It's more of a toy physics than Bondbreaker, but like Bondbreaker, it depicts these links between the objects, like they're lightning bolts. There are various times I talked to a bunch of game designers about this, and they were like, yeah, so if you have there's some reason why something over here causes a change to something over there, you will put it on your to-do list, your game designer's to-do list, to clarify that connection by having a laser go, or having a shockwave go, or something like that. Or say it's a switch and a door, you will have a wire going between the two, or something like that in general. And there are there are times that developers have trolled players by having action at a distance. I would say also that doesn't really count. So Duelist and At a Distance, these are two games I haven't played, but I've been told about them. But the people who told me about them were they're making a point by putting that in the game. And again, I claim I've gotten a bit conspiracy theorist about this, because I feel like the Nintendo DS and the Wii U beg for action at a distance. Like when I was having ideas, what would I put on the Nintendo DS? All of my ideas were there's some interesting connection between the top screen and the bottom screen, and you're working out that interesting connection. But yeah, what I think happened is that there are lots of game designers that had ideas like that, and then they tried them on a Nintendo DS dev kit, and they realised that it was a bad idea. Same with the Wii U. Yeah. The way that the Nintendo DS, insofar as you use both screens at the same time, in general on the Nintendo DS, you have a simple input method on the bottom, and you're seeing the game state on the top. So like the bottom screen is purely an input method. You don't even necessarily need for a lot of games a visual. It doesn't even need pixels, right? You never look at it. You just use the stylus on it. Here's, thinking about it for quite a while, because I do like the Nintendo DS. I did find a sort of mini genre of game, which you might call a dual platformer, which is where you have two avatars at the same time. There are a bunch of games like this. They're not all on the Nintendo DS. These are the four I found on the Nintendo DS, and they feel weird, and they are the simplest form of action at a distance, because the avatar on the top and the avatar at the bottom mimic each other's moves to a very, very large extent. Like, it's basically, the relationship between these two things is they do the same thing. And, by the way, I played all of these games. The Divergent Shift is a really good game. It's impossible to find. Let me know if you'd like to play it. Maybe in the comments on YouTube or on Twitch, and I can maybe sort you out. It's the best. Mighty Flip Champs is pretty good. Chronos Twins, in spite of being the most famous, is the worst. Yeah. The gravity gun from Half-Life is kind of action at a distance, but in another sense, like, it is a gun, right? A gun, you have this thing, and there's like a straight line. So there's a straight line, and when you pick something up with the gravity gun, it has to be within your line of sight. And so there's a sense in which when you think about it as a gun, you've got, you're thinking about making the crosshairs collide with the thing that you want to pick up. And so, again, I would claim it doesn't count as action at a distance. Hopefully this doesn't sound too ad hoc. I can understand why it might. Yeah. Another thing to point out, another reason why you might expect action at a distance to come up in video games is because there are lots of comic book characters who have action at a distance powers, and film characters. Like, it's an archetypical awesome power, right? Here we've got Magneto and Storm from X-Men, and they both, love picking things up and like moving them around and like having loads of stuff happen. Like, they gesture somehow and some shit happens. Without them touching it. And yet, in brawlers and fighting games, to my knowledge, there's no sophisticated action at a distance, and even when these two characters, Storm and Magneto, are depicted in this, I am told, good game, Marvel vs. Capcom 2, that was made by certainly Marvel vs. Capcom 2 was made by very, very experienced fighting game designers. They totally strip away Magneto and Storm's like thing that makes them great, and they turn them into a bunch of kung fu characters, with the exception of their super moves. But again, the super moves hold a rather exceptional situation. They act like normal kung fu characters. One friend of mine pointed out that that could be sort of laziness on the part of the developers of Marvel vs. Capcom 2, because Street Fighter 2 works using action at a distance. No, sorry. Street Fighter 2 does not work using action at a distance. Street Fighter 2 is about kung fu characters, and they might have wanted to just slap on, skin. But, I mean, they must have tried it, right? Like, definitely, and as experienced designers, they decided not to give you the ability to, like, pick some character up in a weird way and have some weird, interesting connection going. So yeah, claim is that video game developers consciously avoid action at a distance. Oh yeah, and one last thing. Jean is another character that can do action at a distance in the comic books, and she's not in Marvel vs. Capcom 2. Yeah. So, why have game developers avoided action at a distance? Two reasons, I would say. Like, partly, it's easy for them to avoid action at a distance because a game developer's ideas tend to come from real-world experience. That might sound like a bit of a weird thing to say if you're thinking about like a game with Spider-Man in it, but like at least Spider-Man is sort of grounded in human capabilities. Like he does things with his hands, and in general in a game, yeah, it's some kind of riff on reality. So this is a screenshot from Rhythm no Tengoku, which is a really or Rhythm Paradise or Rhythm Heaven, blah blah blah. Really great game, and yeah, there are tons of abstract things in that game. Very abstract, but never any action at a distance. And there's another reason, though, which is that I think that game developers do this consciously. When I think about game developers that I like, Kim Swift, Jan something or other, Jeff Minter, these are skilled craftspeople who know what people expect from computer interaction, and they would get rid of action at a distance if they found it to be there in their games. And one last reason why this is a bit weird is that like collision detection is sort of difficult to set up. Like it's not that hard, but at least when I program it, I have a certain sense that like this is not a very mathematically natural thing in comparison with, say, force and velocity and parabolas, projectiles, lots of the things that you implement as mechanics in a game feel simple in the code. Collision detection doesn't feel like it's that way. It feels like this imposition that you've got to make on this pure platonic realm of the video game prior to the existence of collision detection. But collision detection is a really important thing from the point of view of human intuition. We spend our whole lives colliding with things, and so you got to put it into pretty much every single game. Pretty much every single game. Maybe nobody sympathises with me on that, but yeah, let me know if you sympathise with me about the unnaturalness of collision detection. Part 3. What does this tell us about explorable explanations? Well, why is there so much action at a distance in explorable explanations? Fundamentally because action at a distance does, in a sense, exist. I didn't say this before, but I stole the name action at a distance from Einstein, and he was saying, yeah, action at a distance does not exist. He was like sort of using the term to like parody quantum mechanics, and I'm a bit of a nerd, and so I wanted to, and it was a name that made sense. But action at a distance, in some senses, does exist. So, gravity, magnetism, like what we were talking about earlier, your nervous system, so when I touch something, I immediately feel the sensation. In actuality, there's like impulses going through my nervous system, but there's impulses going through my nervous system, but I don't think about those impulses, obviously. Electrical circuits sort of have action at a distance. You press a light switch and the light basically instantaneously turns on. But like something like magnets are freaky. They just are. They're just not within human intuition. And no matter how much I look at them, it's still a bit just weird to me that magnets work. There's probably an Insane Clown Posse joke to be made there. I don't know. But, okay, in science, action at distance turns up. In pure mathematics is about these platonic objects, and I don't want to, get philosophical about them too much, about like yeah. But you think about mathematical objects are things like numbers, vectors, domains and codomains of a function or something like this, and these are things that don't collide. What the hell would it mean for 2 to collide with 3? Like, you could think of 2 colliding with 3 and making 5 if you want to, but that's not precisely what happens. Yeah, and so from the point of view of pure mathematics, action at a distance sort of makes sense, and that's why we have all these sort of like mappings. Mappings are being a common thing in explorable explanations. In applied mathematics, it's sort of even worse. An example of applied mathematics is our simulation of epidemiology. You've got like a disease spreading among a population, and you imagine like the state of that population represented as a point in some abstract space, and like there's this group of people, and they are real-world objects, and they're somehow having a relationship with the location of a point in an abstract space. But they're not colliding. They're not even philosophically in contact with one another, because one's an abstract ideal and one is a bunch of physical objects in the physical world. At least that's how I think about them. They don't. Yeah. Equations and events, in applied mathematics, you take a bunch of events, you take a bunch of things, and you say they're described by these equations, but there's no collision between those two objects. Alright. Sorry. I was meant to change the title of this slide. Input problems. Another reason that action resistance appears in explorable explanations is we have a lot of sliders. We design things for touch screens and for mice, which is fine. Happy to continue doing that, at least for a while. Video games have the advantage that they have like a controller, right? You have a controller and you have the game simulation, and there's a sense in which there's action at a distance between these two things. You've got the controller in your hand, but the controller, once you become proficient with video games, fades away. The controller is just an extension of your will or something like this. You don't have to look at the thing, look back at your controller. You don't have to think of them as separate objects. For us, we maybe do have to have separate objects, because we want, with explorable explanations, we want to have sophisticated control methods that allow us to give inputs into systems, but they all need to be something that appears on a web page. It's sort of a somewhat inescapable problem right now that I'd like us to solve. I'd like us to be using virtual reality things. Well, not really. I'd like us to be using game controllers, really. But yeah, continuing on towards the end now, nearly done. I've decided I'm going to adopt the avoidance of action at a distance as something that I hope is like a limitation that will help me generate new ideas. We all know that limitations can be a source for creative stuff. What's it called? For sale, baby shoes never worn. I'm sure you all know that much, and if you don't all know that one, and if you don't, Google for sale, baby shoes never worn. An older tradition of explorable explanations, which I would like to claim that explorable explanations fit into, is illustrative toys. And there's something interesting that happens here. I define an illustrative toy as something. I guess I don't know how to I'll just give you some examples here. So there's a wonderful YouTube channel, Grand Illusions, where there's this guy who just has this bunch of toys, and so many people love these videos. They're such brilliant videos. He has loads and loads of phenomena that he that he displays using his toys. hexaflexagons are a wonderful example of like a toy that you use to think about interesting things relating to state, or whatever else. So this is there's a wonderful presentation by Matt Parker about toroidal vortices, where he makes a few toroidal vortices. You can use juggling to talk about braid groups. You can use bubbles to talk about a few interesting things. They're a wonderful example of, I don't know, of something akin to a Platonic ideal of a mathematical surface in the real world. They're like, you know, minimizing surface area and this kind of thing. This guy Tadashi Takeda, if you like Explorable Explanations, please look up Tadashi's Toys on YouTube. I have had the pleasure of seeing a Tadashi Takeda lecture in person, and it was quite incredible. He gives full, quite sophisticated mathematics, in general mathematics / physics lectures with a series of toys. And all of these things, they are tactile and they're beautiful. They're tactile in the sense that, like, you can imagine just touching them. Even if you don't get to touch them yourself, you can, like, imagine it and you can be like, oh gosh. I love the curves, and I love the weight of Tim picking up this toy. In general, these illustrative toys show you something surprising. In general, they are challenging. So somebody says, oh, how big can you blow a bubble? Or can you think of a combination of juggle throws that hasn't been thought of before? And I'd say that these things are sort of the older heritage of Explorable Explanations. And there's a reason that I bring them up, which is this. Explorable Explanations run on computers. We could have a fun conversation about whether some of these things deserve to be called Explorable Explanations in spite of not actually running on computers, but that would be semantic. Explorable Explanations run on computers, though, so we can do anything. We can do so much. We can depict any old mathematical thing that we like. It won't necessarily be fun, but we can have all sorts of things. So Miagakure, think about something like Miagakure, but Miagakure, in some sense, it's an explorable explanation, and you can't imagine depicting a lot of the things, expressing a lot of the things that Miagakure expresses to you really well without it being a computer simulation. So we can do anything. We can make things like Miagakure, but on the other hand, we can do anything. And there's a sense in which people who make illustrative toys, like Tadashi Takeda, they get a load of cool, intuitive stuff for free, in a sense. I watched a thing about how Pixar makes films, and they were like, man, animation is so hard, which is right. They were like, it's all so hard because you get nothing for free. If you're a filmmaker, you can go and film on location, and you get better sound quality and blah 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 if you use a soundstage, but like, you can go to some mountains, and you didn't make the mountains, but the mountains, and if you put them into your movie, make your movie more beautiful. Not like that for Pixar, and it's not like that for us. We have to create every single behavior ourselves. That means that we have to introduce lots of behaviors from the real world that people expect. One way of thinking about this, there's a video recently by Matt Parker in which he makes... he talks about sphere packing using oranges, and it's an amusing video. It's an amusing video. Why is it an amusing video? Given that sphere packing is something you can just look at a few pictures on Wikipedia, and you've got basically all of the ideas that they're talking about. But there's something really satisfying about seeing them slice oranges. Like there's something tactile about it, and the orange has this like internal structure, that's fun to see and think about. Yeah, and you think about how like it's sticky, and you might say, oh, that sort of distracts from the maths. But if it makes it more entertaining, then, well, yeah, I don't want to go too far down that road. But yeah, yeah, yeah. Okay, and basically reached the end of the talk now. These are the things that I'm taking away, and like, maybe you think that I'm being pretty stupid here. Actually, action at a distance is fine, you reckon, but at least for me, subjectively, it's just a little bit ugly. So I've just decided I'm going to avoid it in my designs. But just as a little epilogue for you, it's plausible to me that it's worth rethinking sliders at the very least. This is something that I've wanted to say for a while, but it's not really worth its own article. Explorable explanations have lots of sliders in them. Why? Because they are a very simple mapping. They make a lot of sense. You have a one-dimensional region of the screen, a line segment, and the slider gives you an idea of the current state, the lower and upper bounds, and like even the idea of sliding it up and causing a change. But sliders have a problem, which is that you grab a slider, you start moving it back and forth, and then you want to look at the thing that it's having an impact on, right? You want to go like this. But you have the problem with the way that you guys are currently doing sliders, which is that if you move the slider to its upper or lower bound, then you move it up like that, and you're looking at the thing, and you're doing this, and nothing is happening. And I would claim that that's a bad thing, because yeah, you've got to like keep looking back at the slider to make sure that you know sort of where it is in its region. People want to look at one thing. They don't want to see a relationship between two things. Proposed solution, and I'm being pretty cruel sitting here and saying, oh, here's some better ways of doing a bunch of things, and not even trying it out myself, but, you know. Solution. The mapping is, instead of having a slider and a line segment, you have a little you just have the bobbin, and you have like arrows suggesting, you know, you can pull this in either direction. But once you grab it, you've grabbed it, and you can take it anywhere you want, and it's just the case that when you move it to the right, it will increase the value of whatever parameter or whatever it is that you're controlling. It will increase that, and if you hit the limit, you sort of have your simulation like, you've hit the limit, and now it just goes, but then it sort of retracts a bit somehow. And then when you move it back to the left, no matter where it is, this is the point, you don't have to look back at it to see, am I allowed to, yeah. No matter where it is, even if they've moved it really far over here, they can move it to the left, and it will cause the parameter to go down. It's simpler, and I would claim it's more functional. And okay, so there I will end it. I hope that this has persuaded you to maybe not have action as a distance in your explorable explanations. And now I'm going to look at the chat, and maybe you're all telling me that I'm a complete idiot. This will be fun. As long as I've started some discourse around this. Maybe I'm completely wrong, but, you know, yeah.